Conceptually, we can divide the evolution of stars into three rough stages. The early stages, or pre-main sequence stages of evolution, the main sequence itself, when hydrogen is converted into helium, and post-main sequence stages, which vary depending on the mass of the star. To take the example of the Sun has spent roughly 30 million years reaching the main sequence. We'll spend 9 billion years in total on the main sequence, followed by about 1 billion years as a red giant, and then a large or essentially infinite amount of time as a cooling white dwarf. What this implies for censuses of stars outside the main sequence is that the visibility of a star depends roughly on the amount of time that it spends in each evolutionary stage. So if a star like the Sun spends less than 1% of its time reaching the main sequence and about 10% of its time as a red giant, then if we surveyed 100 stars like the Sun at different stages of their evolution, we'd find only about one on its way to the main sequence. 90% we'd find on the main sequence, and about 10% we'd find as red giants. This is not the whole truth, however, because the different evolutionary stages have different luminosities, and short-lived but luminous stages of stellar evolution are much more visible than long-lived or dim stages of stellar evolution. Thus, the stellar catalogs are overrepresented in the short-lived luminous phases, such as red giants and, of course, supernovae.